Today we're going to learn how to connect each point to every other point in a geometry. You'll be able to create incredible, beautiful geometries. So let's see. Okay, first of all, let's go to Geometry Nodes with a new profile. I will close this, today we don't need it. And let's use for this example to understand how it works, a curve cycle. Is the best example to understand this. Let's zoom this and select this view and hide the grid, so we can see better this shape. So with this node, we can select the number of points of this curve cycle in resolution. The minimum number of points is 3, so we have a triangle. If I select 4, we have a square, 5 we have this, etc. Let's select 6, just for the example and to understand how it works. So basically what we want is to do two things. The first thing we want to do is to connect one point to all the other points with lines. So let's say we have this point, and I want to connect this to this point, to this one, and to the other points, right? We want to do this. This is the first thing we want to do. And the second thing is to repeat this process for each point. So we want to do this, this, and at the end, if we repeat this process for each point, we have something like this. Depending on the geometry, we will have a different pattern. Okay, so the question is, how we do these two things? To do these two things, what we have to do is to work with each point separately. So we need to use for each element. To use this node, you need at least Blender 4.3. So let's connect this here, the input, and here we have two outputs. If you connect the first one, the top one, you will show the original geometry without showing what happens here. We don't want that. We want to use this one, because this one is going to show you what we do here. Okay, now we cannot see anything because we don't have anything here. So how this works? Basically, these two nodes works with elements, with each element. So what is an element? An element is, for example, a point, edge, face, face corner, spline, instance. So we need to select with which element we want to work. What we want is to work with each point because we want to instance a curved line in each point to connect it to other points. So we're going to select point. And now in this blue zone is going to apply something for each point. So whatever we insert here is going to repeat it, for each point. So if I use, for example, a curve line, because we want to instance lines, and I connect it here, if I move the camera, you see one line. But actually, there is more than one line. So if I go to the spreadsheet, you will see that we have 6 splines, 6 lines. So this is really important to understand how this works. What it's doing is that for each element that we selected, in this scenario we are working with points, and this geometry have 6 points, is applying one copy of this. So we have 6 curved lines. Okay, if you understand this, we are improving. Okay, now let's close this. All the lines are sharing the same start and the end. Here I can control the start and the end. That's why we see only one line. What we want is to connect these lines to all the points. So what we can say is that at least what we want is that the start, for example, or the end, it doesn't matter, but let's say the start, have to be in the original point position of all the points. So how we do that? How we say the start to be, for example, in each position. So to do this, we need to use the position node, because the position node have the information, the position of all the geometry, all the elements in a geometry, right? However, if we connect this here, as you can see, it doesn't work invalidly, because these two sockets are different. This only accepts one single position, not all the information of the position of a geometry. So we cannot do this, but thanks to for each element, another superpower that I have is that whatever field that you connect here. A field is this type of socket where we have a lot of information in one single node. So if we connect a field in these empty sockets, it's going to split this information for each element. So here we have this socket, and basically we have the position for each point in different rooms. Remember that we see only one setup, but it's like if we have this setup multiplied by 6. And when you see this wire, I have different positions. So the important thing to say is that now we can connect this to here. Look. And all the stars of the copies of the 6 lines that we have, that now we can see all the 6 lines, are connected in the position of each point, because we're working for each element. Perfect. So now we have one part of the job done, and as you can see, all the end lines are connected in the same position because they are sharing the same position. So now how we say the end have to be in the position of all the rest points, or all the points. This is a bit complex to do, but I'm going to show you how I discovered to do this. So what you cannot do is to use the same logic and say, okay, let's apply it to the end, because then it's going to disappear. Because basically the start and the end is going to be in the same position. So if this is the point, the start will be here and the end will be here, right? So that's why we don't see any line. We don't want that. So how we do that? What we do now? Okay, now I'm going to try to show you something a bit complex to understand, but don't worry, it's easier to do. So let's see which index have each point. If we try to see the index from the original geometry with Ctrl-Shift left click, and we use index, and we activate the attribute text, you can see that this one is the index 0, and then it follows an order, right? So 1, 2, 3, 4, 5, etc. Okay. This if we make a preview of the original geometry and its index without using this. However, now is the interesting part. If I use this index, look at this. This is really important to understand. All the index are 0. Why? How is this possible? In theory, this wire have all the number of this index, and this is true. But when we use the viewer node, we are seeing all the points connected because I'm using this. Look, if I use this, now we see only 1, 0. But basically, when we have a point inside this room, remember it's like having 6 rooms. So it's like having 6 isolate rooms. So that's why if I try to see it from the original geometry, but using this index, it says 0 because each point is isolate. It's like having a room for each point. So if all the points inside for each element are isolate, that means that this point doesn't have more points, so the index is 0. It's the only point that is inside this geometry. Okay. Maybe you are thinking, and what I can do with this information? So, if all the points inside this setup are 0, what we can do is to say, can you connect the end to the index 0? That means to all the points. And maybe we can get this effect to connect all the lines to all the points. So, let's try what I did first. That was to use sample index, because we want to get the position. So let's select vector. We want the position of the index 0 because all the index are 0. Do you remember? Okay. And what we should get, this or this? So in theory, we should get this. But first, let me show you what happens if we use the outside geometry, the original geometry. So if we get the position of the index 0 of the geometry, and I try to connect it here, basically what is happening is that all the end lines are being connected to the, remember, the index 0. This one. So that's why all the lines are connected there. And if I select 1, all the lines will be connected to the index 1, 2, 3, etc. So we cannot use the outside geometry, the original geometry, because all the indexes are normal, following a sequence. Okay. So what if we use element? Let's try to see if it works. And let's select 0. If not, it won't work. It doesn't work. Why it doesn't work? Because if you remember that each index is 0, basically what we are saying is connect the end to the same position that the same point. It's basically doing like that. So do you remember like this? We connected the start to all the points. If I do like this and I disconnect this, you will see that is the same. Now the end is connected to the position of the original position. So basically, if we connect this here and this here, we have the same effect like doing this. So it doesn't work. Okay. As you can see, it's a bit tricky to understand how this works. So, Shan, which is the solution? I just want to connect all the points together. Please show me how to do this. Okay, don't worry. By the way, if you're enjoying this tutorial, please hit the like button because this helps me to promote this type of tutorials to more people. So I will appreciate it a lot. Thank you. So the solution is to use another for each element. So we're going to do like Inception movie.
You create the world of the dream. We bring the subject into that dream and they fill it with their subconscious.
A dream inside a dream. So let me add some knobs here. By the way, if you are wondering, if I use this here, look, it do this. So it doesn't work, okay? That's not a solution. So let's go to the solution. What we have to do is to use another for each element, because remember, we have 6 lines. But basically what we want is more lines. With 6 lines, we cannot connect everything together, right? We need a lot of lines to connect everything. So that's why we need another for each element. Okay, now the real question. How we connect this? Where I start? So the tricky thing we have to do is to connect this with this. So let's connect this with this. So basically we're going to do copies of copies. And now we have to open this because these have to be here. And we need to sample this here. If not, it's not going to work, of course. And this here. And as you can see, it works. So this is the setup. I know it's a bit confusing. It was for me, but it works. That's the important thing. So to sum up, basically, it's a bit hard to explain, but it's like, thanks to this copy of for each element inside another for each element, we are saying connect all the end lines to the index 0. And if you remember that before the index 0 was all the points, once, remember, very important, once we work inside the first for each element, basically we are saying connect the end to all the points. So more or less, this is the theory and how it works. I know it's confusing, but it works. It's not really complex to do, as you can see. It's just confusing to understand. But the important thing is that we get this beautiful effect. And now you can increase this, and you will see that we have these beautiful geometries. More you add, more lines we have. And you can apply this, of course, to 3D objects. So let's use, for example, a cube, and let's see what happens. As you can see, all the points are being connected. One important thing that you have to know is that more points you add, more lines we have. And it can take a lot of computing, because look at this. If I open the spreadsheet, look how many lines as splines we have with this number of points. But if I add 3, we have already 3 times. If I add 4, it's increasing a lot. As you can see, it's going crazy and crazy. So be aware if you have a lot of points, because I did a test with a lot of random points and Blender just crashed. So be aware of this technique. But as you can see, we can create really beautiful geometries with an icosphere, And if we subdivide this one step more, look how crazy it is. Now, I want to tell you two important things. Let's come back to use the minimum number of points, because you have to understand one important thing. When we use this setup, you will think that we have only 3 lines. 1, 2, 3. But this is not true. Look at here. In spline we have 9. How is this possible? This is possible because remember that basically what we are doing is to say to each point, connect it to the other points. So this point is going also to connect it to this point. And to this point, and this point, it will be connected to this point. So what is happening is that we are having duplicate lines overlapping in the same position. And also you will notice, okay, here we have 1, 2, 3, 4, 5, 6. 6 lines, 6 splines, and it says 9. How is possible? Because also what is happening is that the points are being connected to itself. So it's like having a line connected to itself. So that's why we have 9, because we have 6, 7, 8, and 9. 9 splines if we use a triangle. So the real question is how we optimize this, how we delete overlapping lines. To do this is really easy. The only thing we have to do is to convert this geometry to a mesh with curve to mesh. Let's add it here and use, maybe you are guessing, merge by distance. And now if I convert this again to a curve with mesh to curve, you will see that we have only one single spline. So look, to show you what was happening before, that I forgot to show it, let's use set position. So we have 9 splines, and you don't believe me that we have 9 splines, so it's okay, don't believe me. I'm going to show you how to do it, how to see it. Let's use combine, and we're going to use index in Z to move each spline, each line. And now you're thinking nothing happens, but look, let's move the camera. Ooh, an illusion. So let's decrease this, the distance, with math node, and let's select multiply. And if I decrease this, now we can see better all these duplicate lines. Remember we had like 9, and now you can see that we have duplicate lines in the same position, and these little lines that I told you before, that is that the same point is being connected to itself. So that's why we have 9 splines here. But after this, we have only, by the way, let me delete this, we have only one single spline. And you can see this improvement if, for example, we select, I don't know, for example, 10. So now we have 45 splines, and without that, we have the double, 100. So use this to delete overlapping or duplicate lines. And if you want to rebuild these lines, you can use, before of this setup, a trim curve, and you can do this effect. I think it's not connected. Yes, it's connected, but it's not working. Ah, yes, now it's working. So you can do this effect. And now you know how to do it. What you can do is to convert all the lines to a mesh. So if you like this video, please give a like, subscribe, and remember, you can download this project and many more than 100 on my Patreon. And see you in the next tutorial.